Since I'm working with another group during class, I wanted you to be able to have access to explanation if you were stuck on any of these problems. So this is explanation of workbook page 7. We covered this material in class on Monday, but I felt like maybe we needed a little more practice with it. If you just need to check your answers with the key, there's a key posted on Canvas. This is more for if you don't understand where the answers are coming from. So let's get started. I have a copy of the unit circle pasted up here on your quizzes and tests. That will be blank and you'll have to fill it in. So you need to continue to work on memorizing that. All right, so what I need to remember is that in trigonometry, sine refers to y values and x refers to cosine. Cosine refers to x values. So when this says sine of 45, what I'm really looking for is where is y 45? So, what is y at 45? So I go to this 45 degrees and I look at the x and y values. I want the y value, which is root 2 over 2. Cosine of 60, well, cosine's x. So I want to go to 60 degrees and I want to look at the x value at 60 degrees. And that's 1/2. Secant of pi over 3. So I'm going to go to pi over 3. Well, secant goes with cosine. So let's think about what the cosine of pi over 3 is first. So what is the x value at pi over 3? Well, the x value at pi over 3 is 1/2. So to get the secant of that, I'm going to need to flip this fraction. So it's 2 over 1, and then that's 2. So the secant of pi over 3 is 2. And then the cosecant of 60. So I'm going to go to 60 degrees again. And I want to look at cosecant. So I know cosecant goes with sine. So first I'll look at the sine of 60. Well, the y value at 60 degrees is root 3 over 2. So if I want the cosecant, I'm going to need to flip this. And if I flip this, I get 2 over root 3. And I'm going to need to rationalize that because I can't keep a root in the bottom. So I end up with 2 root 3 over root 9, which is 3. So the cosecant of 60 is 2 root 3 over 3. All of these were pretty straightforward because all of these angles were in quadrant 1, so I could just refer directly to my unit triangle or my unit circle to get my answers. Now the problems start to not be in quadrant 1 anymore. So the first thing I want to think about is, well, what quadrant is it in? All right, so when I think of 225, I know that this is 0, 90, 180, 270, 360. So 225 is somewhere between 180 and 270, which means it falls in quadrant 3. All students take Calc. In quadrant 3, tangent is positive. So right now, I'm trying to find sine, which means my answer is going to be negative. So when I get to the very end of this problem, I'll make sure that my answer has a negative with it. The other thing I need to do is find my reference angle so I can refer to quadrant 1 of my triangle. It sometimes helps to draw this because some of you didn't memorize the rules, you used pictures. So what we have is 225, but what we want is this little portion. We want to get rid of all of this. And that pink right there is 180. So to find my reference angle, I'm going to do 225 minus 180. Just remember, we don't have a calculator, so we have to do this math by hand. 5 minus 0 is 5. I can't do 2 minus 8, so I'm going to borrow from this. That changes that to a 1 and this to a 12. 12 minus 8 is 45. So my reference angle is 45. So I'm going to go to quadrant 1 and I'm going to use the 45 degree coordinate points. And since I want to find the sine, I want to focus in on the y value. So I know my answer is going to be root 2 over 2. And then I also know that since it's in quadrant 3, I have to add a negative to that because sine is negative in quadrant 3. For the next one, 2 pi over 3. Well, let's think about what quadrant that's in. 2/3 is the same thing as 0.67 pi. So in terms of 0.5 pi, 1 pi, 1.5 pi, 2 pi, 0.67 is somewhere between 0.5 and 1. So this is going to be in quadrant 2. And all students take Calc. S is in quadrant 2. Sine is positive in quadrant 2. So since I'm finding a sine and it's positive in quadrant 2, I know my final answer is going to be positive. Now what I need is my reference angle. The reference angle for radians is actually really easy. Since the denominator of 2 pi over 3 is 3, then my reference angle is the only angle in quadrant 1 with a denominator of 3. And that's pi over 3. And here's the coordinate points at pi over 3. Since I'm doing sine, I want to focus in on the y value. I'm not going to add a negative to this since quadrant 2 sine is positive. So my answer is just root 3 over 2. Cosecant of 315. Well, let's just start with our quadrant. 315 is somewhere between 270 and 360. So this is going to be in quadrant 4. Cosecant pairs with sine. So really I'm thinking about what do I know about sine in quadrant 4? Well, quadrant 4, cosine's positive, but sine is negative. So I know my final answer is going to be negative. The next thing I need to do is find my reference angle. It might help to draw a picture here. It's going to be something in quadrant 4. Here's what I know, that's 315. Here's what I want to know. It's the remaining piece of that full circle. So to get my reference angle, I'm going to do 360 minus 315. Remember, I don't have a calculator, so I'm doing this by hand. I can't do 0 minus 5, so I'm going to borrow, and that 6 becomes a 5, and the 0 becomes a 10. 10 minus 5 is 5, 5 minus 1 is 4, 3 minus 3 is 0. So my reference angle is 45 degrees. My coordinate point at 45 degrees is root 2 over 2, root 2 over 2. Since I want to find the sine, for now, that's the y value. So I know that the sine of 315 is negative because sine is negative in quadrant 4, and then the y value that I referred to is root 2 over 2. But I want the cosecant of 315. So what that means is I'm going to have to flip this fraction. And then I'm also going to have to rationalize the denominator. So I get negative 2 times root 2 over 2, because root 2 times root 2 is root 4, and these cancel out. So my final answer for this one is negative root 2. Right, for the next one, sine of 7 pi over 6. Well, I want to figure out what quadrant this is in. So I'm thinking about 7, 6. That's 1 and 1/6. So in terms of 0.51, 1.5, well, it's 1 and 1/6. So I know it's more than 1. And 3/6 is a half. So it's less than 1/6 is less than a half. So this is somewhere between 1 and 1.5. So this is going to be quadrant 3. And since I'm working with sine, I know that sine is negative in quadrant 3. Only tangent is positive in quadrant 3. So my final answer is going to be a negative. Now I need to find my reference angle. My reference angle is really easy for these. The only angle in quadrant 1 that has a denominator of 6 is pi over 6. So I'm going to use the pi over 6 coordinates. And since I'm working with sine, I want to use the y value. But remember, this is a quadrant 3 angle, and so my answer should be negative. So I'm going to add a negative to this 1/2. So my answer for this one would be negative 1/2. 5/6. The first thing I want to do is figure out what quadrant that's in. Well, if I'm comparing it to 0.5, 1.5, 2, 5/6 is less than 1, because 6/6 would be 1, but it's more than a half, because 3/6 is a half. So it's somewhere between a half and 1, which puts me in quadrant 2. I'm also working with secant, which pairs hand in hand with cosine. So what I know about cosine in quadrant 2 is that it's negative. Sine is positive in quadrant 2, but cosine is negative. Now I need my reference angle. It's pretty obvious since this is a pi over 6. The only angle in quadrant 1 with a denominator of 6 is pi over 6. So the coordinate point at pi over 6 is √3 over 2 and 1/2. At first I want to work with cosine. Cosine is the x values. So the cosine of 5 pi over 6 is going to have a √3 over 2. But because it's in quadrant 2, we talked about how it would be negative. I want the secant, so what I need to do is flip this fraction. And when I flip this fraction, I get something that needs to be rationalized. So I'm going to multiply the top and bottom by √3. So I get negative 2√3 over 3. So my final answer for this one is negative 2√3 over 3. All right, sine of 330. I want to think about what quadrant that's in. That's going to be a quadrant 4 angle. It's bigger than 270. It's less than 360. And I know cosine's positive in quadrant 4, which means sine is negative. Now I need to find my reference angle. It might help to draw a picture. Here's an angle in quadrant 4. This is 330. This is what I want to know. Together, that's 360. So I'm going to do 360 minus 330. 0 minus 0, 6 minus 3, 3 minus 3 is 0. So my reference angle is 30 degrees. So the coordinate point that I'm going to use is the coordinate point at 30 degrees. And since I'm working with sine here, I want to use the y value of that coordinate point. And since sine is negative in quadrant 4, my answer is going to be negative 1/2. 225 is an angle that falls somewhere between 180 and 270. This is a quadrant 3 angle. And cosecant pairs with sine. So what I know about quadrant 3 is tangent is positive, which means sine is negative. My final answer is going to be negative. Now I need to find the reference angle. It might help to draw a picture. So here's what I know. Here's what I want to know. That little piece, I need to subtract this part from. This is 180 degrees. So to find my reference angle, I'm going to take 225 and I'm going to subtract 180 degrees. 5 minus 0 is 5. I can't do 2 minus 8, so I'm going to borrow and make it 12 minus 8. So my reference angle is 45 degrees. So I'm going to use the coordinate point at 45 degrees. I'm going to start with the sine, and that sine is a y value of √2 over 2. So the sine of 225 is √2 over 2, but remember, because it's in quadrant 3, it's negative. To get the cosecant, I'm going to need to flip this fraction. And so I'm going to do 2 over √2, and then that's negative because it's in quadrant 3. And I have to rationalize this. So negative 2√2 over 2, and those 2's cancel out. So my final answer here is negative √2. Last one, secant of 5 pi over 4. This is like 1 and 1/4. So it's more than 1, but 1/4 is less than a half. So this is something in quadrant 3. And secant pairs hand in hand with cosine. And in quadrant 3, I know cosine is negative, meaning my final answer to this problem is going to be negative. My reference angle is pretty obvious because there's only one angle in quadrant 1 with a denominator of 4. So the coordinate point I'm going to use is my root 2's. And first I'm going to have to work with cosine. So the cosine of 5 pi over 4 is going to use the x value of that quadrant 1 answer, which is root 2 over 2. But because 5 pi over 4 is in quadrant 3, I have to add a negative. When I want to do the secant of that, I'm going to have to flip the fraction. And I will rationalize the denominator. And what happens here is the 2 cancels out, so I get another negative root 2. I hope this helps.